Matthew?
Yep.
Okay, and where are you asking to take early?
I didn't even get to finish it, so a lot of times.
Well, it's not due till tomorrow. And tomorrow, okay. So which one particular?
First, let's just focus on number 5 for the first bit.
This one here. Correct?
Because how do we implant the stream in between sine and x? Because if we multiply by 3, we'd have to put the stream in front of the sine.
Okay, so I'm going to do this. This is a scalar. So I can write this as 3 times the limit as x approaches 0 of x over the sine of x, correct?
I did not know that.
Right, because this means 3 times x, right? I can actually write this as 3 over 1 times x over the sine of x, correct? Right?
I never realized that.
Okay, and so since it's a scalar, I can bring it out, and this limit is 1, so the answer is just going to be 3 times 1. Everybody okay on that? How I did that? Any other one, Matthew? Or anybody?
Well, probably a lot of the stuff on the back, most likely.
Okay.
Anyone else have any questions on this? Because I'm only going to give out one because I'm going to have to figure it out on my own as well.
So, what are you looking at here?
Well, a lot of the stuff, really.
Well, here you're going to factor, correct?
Okay,
And
so-
hopefully the x minus 4 factors out. And if it doesn't, so I would say, hey, like this, 5x squared. Can I take 5x and over here have x minus 4? Does everybody see why I choose x minus 4 as a factor?
Yeah.
Okay, and if I can't factor it, where x minus 4 is a factor, can you see why does not exist would be your answer, because you would have x minus 4 in the denominator, which you need to get rid of,
That makes a lot of sense.
okay?
Could we
So-
try one of the, like, 23 and 25?
23,
Yeah. Because I really feel like that is a, like, how we, like, the 1 minus cosine squared x. I really feel like that would be changing that into a sine squared x.
yeah, you don't want to do that. I kind of gave you a hint like this last time. I think Tyler factored these, am I right, Tyler? No, you didn't? No, you did. And down here I can do this. Would everybody agree? Okay. So I have this one. Correct? Does everybody see? Because I can rearrange these any way I want because I'm multiplying, correct? And then I can take the limit as x approaches 0. Do you have one that says 1 minus cosine x? This x is over here, right? Do you have one, if you look at yesterday's notes, and I don't know if I have one right here. Didn't you have something with like 1 minus cosine x over x or 1 plus cosine x over x? Which one did you have? So I can say I have 1 minus cosine x over x, correct? And then I can say I have a third limit. The limit as x goes to 0, what's remaining? 1 plus the cosine of x, correct? Over 1. Would everybody agree with that, that I can break it up? I have 3 fractions here. Am I losing you when I write this?
Kind of.
Well, the reason I choose this is one of the special trig ones. This is 1, right?
Okay.
This one is 0, correct? And I'm multiplying by 0, correct? When you multiply by 0, that's wonderful, because you always get what is your answer. 0. So the answer here's gotta be 0.
The entire answer?
Yeah, because I don't care what this limit is even, because when I multiply by this one, which is 0, everything's gonna get 0. Because I got 3 limits I'm multiplying by, and one of them is 0.
We can also save them from being D and E as well.
Well, it won't be D and E, it's actually 0.
Yeah, that's what I said. We saved it from being that.
Okay, and you want me to talk about this one right
25,
here?
I feel like that's a trigonomic function right there.
Well, this is what I'm going to do, okay? I'm going to bring out the 4, and I'm going to have the limit as x approaches 0, and I can factor out a sine of x, and I'm left with cosine x minus 1 over x times x. Would you agree with that?
Yes. Wouldn't that make it 0? This entire problem?
And this one's backwards. Would you agree?
Oh, so
Right? So I can do this. A negative 4, I could factor out a negative 1 here. And it's a number, a negative 1 is a scalar, so I
1
can
minus
bring...
cosine of x, which makes it 0. The entire thing is 0.
Correct. So this one would be 1, and this one would be 0. And you know, you're going to have 2 limits. You got negative 4 times this limit, but since that one is 0, that's got to be your answer.
Okay, so I think I'll probably be able to finish this today then.
It's not due till tomorrow.
I know, but I'll probably be able to finish this today.
And the other thing I want to talk about is, did you have any problems with number 2, or were you okay with that?
Was the answer for number 2 0 and negative 2 over 3?
Well, this is, okay, can I tell you how I'd approach it?
Sure.
Okay. I would write this as the limit as x approaches 2 of f of 2 of x minus the limit as x approaches 2 of f over x plus, or x over 2. Would everybody agree with that?
Yes.
Now, when I look at this, I have the limit as x approaches 2 of f of x, not 2 of x,
So
right?
we multiply the x,
Okay.
so we change the x approaches to 2 to x approaches 4?
Correct. So if x is approaching 2, what I'm inputting into f is approaching 4, correct? In other words, as I approach 2, I would have 1.99999, and I multiply it by 2, that's really close to 4, correct? And on the other side, it'd be 2.0001, and when I put that in, again, it's really close to 4. So what I can do is I can rewrite this as a limit as x approaches 4 of f of x. These two limits are identical, aren't they?
Yep.
Then over here, when I put 2 in here, it's like it's approaching 1 because 2 divided by 2 is 1. So I can write this, the limit as x approaches 1 of f of x. Did I lose anybody in that? Is that making sense where I got the 4 and the 1? So now I come up here, do I have a 4? Yeah, I do. So this is going to be 2 minus, because this one's 2, this limit is this one, so I have 2 minus 6. I get negative 4. Was that helpful?
I got 0. I realized where I went wrong on that. Because because it was a fraction, I thought if we multiply by 2 on the bottom, we get just x. So I put it on x approaches 4 on that as well. I realized where I went wrong, and I changed it accordingly.
Okay, good. Okay, so my explanation was okay?
Yeah, your explanation was good, so now I'm gonna have to rewrite just a teensy bit of stuff and we'll fix it.
Does anybody have any questions that they want clarified? Colin, everything okay? Okay? Because today is gonna be an algebra day. Because this is kind of analytical, right? X is approaching 2, but inside it's approaching 4, so you can rewrite it. This is going to be like, you know, there's 2 parts, Jonah, in calculus. There's the analytical or the creative part where you got to learn how to turn the corner and view a problem from a different end, okay? And then there's the mechanical part where you just grind it out, okay? Today's a grinding out day. Okay? And I'm going to be reviewing some, I hope, are advanced algebra topics. So, I did this already.
So now that you posted the answer keys, that will be extremely helpful.
Yeah, and I posted the answer keys too.
Yeah, that will be helpful as well.
Yeah. I was going to do that if somebody came in. I need to do that. Make sure there's 2 sides. Sometimes I accidentally hand out, I don't know why, a one-sided copy. Hi, Maria. How are you today? Good. Doing wonderful. I went to bed early. Hey, can we put the computers away? Oh, where's the other end of this? I guess I'm a copy for myself. All right, so the issue we have on limits, the best way, Owen, to do limits is plug in a number, everything works, you don't have division by 0, you don't have the square root of a negative number, bam, you get a number. That's the best thing,
Yeah,
right?
the
Okay? And then
optimal
factoring's
situation.
not too bad. Do you like to factor, Owen?
I don't.
Oh, really? I loved factoring. That's why I did not go into engineering, because I knew that they did not factor for a lifetime. And that's what, so to me, it's like a little game, you know. That's too bad. Okay, well. I think figure out limits, factoring, and that feeling of removing the denominator gives me joy. Okay, maybe you'll be there someday. But the ones that cause us the problem are the ones that look like fractions, the ones that we call rational expressions, correct? So I'm gonna do a little reviewing here. And it says, here I got a complex rational expression. It's just a bunch of fractions over a bunch of fractions. And they're really, 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 really tiny, Ariana, and I don't know why. So I'm gonna make them big. Okay, is that big enough? Okay, and long time ago, remember I say we come back to stuff that you had, and what we do, unfortunately, as math teachers, is we teach you something and then we go on, and we never, we have a tendency not to expect you to know it again. Well, that's wrong. I grew up in a welding shop. I was working full-time as a 9-year-old. Think about that. I put in 40-hour weeks in a welding shop, making $0.25 an hour, and I thought I was rich. It was 1967. But that's where I learned my fractions. And so you have to get this thing called a common denominator. Now I chose very specific ones because this one, the common denominator is 12, and I can get that by multiplying by 3 times 4. Would everybody agree with that?
Mm-hmm.
So on top here, I'm going to multiply the top and the bottom by 3 and get 9/12. and I'm gonna multiply the top and the bottom by 4 and get minus 8/12. Are we okay with that? And then down here, the common denominator is 6, so I have 1 6 plus 3 6. And this gives me 1/12. This gives me 4 6, which is 2/3. And the way that you were probably taught to divide fractions is multiply by the reciprocal.
And is that correct?
That's correct. You don't have to always multiply by the reciprocal. There are times you can divide straight across. You'll see me do that at times. Don't worry about it. You can always, I remember doing that with, I had the valedictorian class, she said, will you stop doing that? And I was getting the right answer. She says, I want you to multiply by the reciprocal. So for her, this was like 10 years ago, I quit doing that, but I might bring it back to this. And so I get 3/24, which is 1/8. Oops, this is way too big. I'm gonna make this a little bit smaller.
I condensed that all by just basically doing most of it in my head.
Right, and and that is A-okay.
Should I
Okay.
write down what you wrote down though?
So what steps did we do? We found common denominators. And secondly, we multiplied by reciprocals. So now we have this one right here. And so we're learning to rewrite these because when we get them as limits, we're going to rewrite them and then we will be able to solve our limit. Okay? So we're just reviewing this because what has happened in the past, after you guys take the AP exam, you'll get your scores in July. It's usually like July 6th, the 5th, 6th, or 7th, right after the 4th. I also get your scores, but then later on, I get a report on what you did really well on and what you didn't do so well on, and that's basically my report card. And then I may adjust accordingly with my curriculum so I can hit those problems. That's what I do in the summertime. And one of the things, and I think it's due to COVID, was that there was some struggle with some algebraic skills. So I'm bringing those back just to do a little bit of review. I haven't done this in the past, but I think it'll be worthwhile to do. So over here, there's nothing to do with this 3 over x, but I can get a common denominator on the bottom, and the common denominator is 4. Would everybody agree with that?
Mm-hmm.
Now, I am going to take some liberties here, and I'm going to write this. As one fraction. Does everybody know where the 2 plus x squared over the 4 came from?
I do.
Okay, good. Everybody okay with that? Right? So now what I can do is I can have 3 over x times the reciprocal, and I'm going to get 12 over this. Now I'm going to make a comment about this. We are going to find out when we talk about derivatives that it is not to our advantage to multiply through. We want to leave stuff factored in the denominator. Okay? So don't go through all the effort to come up with 2x plus x cubed. If you do that, I'm not going to mark it wrong, but later on you're going to have to factor it and solve when you make it equal to 0 because it's going to be telling us some information. So why go through and multiply it if you're just going to take it apart anyway? Callan, does that make sense? Okay. All right, so this next one, I'm going to look at the top. And I'm gonna write this as 3 times x plus 3 minus 2 times x minus 4 over x minus 4 times x plus 3. Okay, so this is just the numerator. So what I did here is I multiplied the top and the bottom by x plus 3. So that would be this fraction. And then I multiplied the top and the bottom here by x minus 4. It's just like multiplying 4 times 3, correct?
Could you
Just a
repeat
little
that?
bit more complicated. Again, I do not take the time, nor do I wish you to take the time to take that denominator and make it into x squared minus x minus 12. Leave it factored. Below, I'm going to have x plus 2 plus x minus 6 over the product of x minus 6 over x plus 2. So again, what I did here is I multiplied this numerator and denominator by x plus 2. I multiplied this numerator and this denominator by x minus 6. Ben, I am so happy you nodded. Okay.
I do
Because
not
when
understand the top bit.
I made a mistake.
I don't know.
What's your question?
Could you rephrase like what you did for the top?
The numerator?
Yeah, the numerator of the numerator and denominator of the numerator.
Okay, so what I did here is the common denominator is a product of these two.
Correct.
So I have to multiply this numerator and this denominator by x plus 3. That's why you see it 3 times x plus 3 here. And then the numerator and denominator here has to be multiplied by x minus 4.
So you multiplied 2 and x plus 3 times x minus 4? You just,
Yes.
so we just did normal stuff and then do
And then I combine them, since I know that's going to be my common denominator anyway.
and you can just do bam bam.
Well, bam bam's coming down the road.
Okay then.
So now I'm going to have, this is going to be 3x, this is going to be a minus 2x, and I'm going to get x. So I'm doing some simplifying in my head, right? 3x minus 2x, they're going to be the same, I can combine them. This is going to be 9, this is going to be a plus 8, that's going to give me x plus 17. Now, if you want to write all that out, feel free to do that. If you want me to write it out because I went too fast, I will do that also. But I want to make sure everybody understands where that came from. And then again, I got x minus 4 times x plus 3 times, now I'm going to have the reciprocal. Down up here, I'm going to have x minus 6 times x plus 2. And on the bottom, I got x plus x, which is 2x. And 2 minus 6, which is a minus 4. And if you wrote this down as the answer, like my father-in-law used to say, and leave it in factored form, I would be a happy camper. Because you don't have to, you imagine if you multiplied that together, and then down the road I'd say, well, guess what you got to do now? Okay? Do you see why I say just leave it in factored form? Example 4. Well, now what I'm going to have, I'm going to have x minus 2 divided by, well, they're already, oops, sorry. x minus 2, they already have a common denominator, so I can say 16 minus x squared over x minus 2, correct? Now, I think I made a mistake. Ella, have you ever screamed at a teacher?
No.
Okay. Don't scream now. I want these to be a plus 2 and a plus 2, so I'm gonna make them plus. Is that a big deal?
Possibly. But you're the teacher, so you have all say.
Okay. And so now this is going to be x minus 2 over 1 times the reciprocal x plus 2 over 16 minus x squared, and I'm going to have x minus 2, x plus 2 over 4 minus x, because these are like what Tyler said yesterday, difference between squares. And there's nothing to cancel out. I was hoping there'd be something to cancel out, but there's nothing. This is going to be 5 over x times x plus 1, because the common denominator is x minus 1 times x plus 1. So I multiply this numerator by x plus 1. I've got a minus here. And I'm going to multiply this numerator by x minus 1. Now this is where students make mistakes. Make sure you put those in parentheses, because you're going to have to distribute that minus sign. And a lot of times that's where people make mistakes, is by when you have a negative in front of here, it's not distributed. Then down here I'm going to have the product of x minus 1 and x plus 1.
So are we distributing or no?
Here?
Yeah.
Yeah, we will. Okay. You can't leave it in this form, and so it's going to be 5 over 1 times x minus 1 times x plus 1, and down here you're going to get x squared plus x minus x plus 1, and that's going to give you 5 times x minus 1 times x plus 1, and x squared plus 1 is non-factorable. We try, and there'll be voodooists that will come up with answers, and they will get it wrong and collect a stamp. Robert? That's Robert's last name. He was really smart. He's the guy I was talking about before. People would ask him for help. He'd do voodoo just to watch them get stamped in class. He was cool. All right, backside. Conjugate. Conjugates are two numbers that are being added together, and the same two numbers are being subtracted. That's a conjugate. My brothers are mirror twins. They're 2 minutes apart. One's named Bruce, the other one's named William. William is 2 minutes older than Bruce. I never call William William, I call him Bill. One is left-handed, one's right-handed, one is nearsighted, one is farsighted, one parts his hair on the left, the other one parts his hair on the right. I have an older brother named Russ. We play golf together. We call ourselves the Stumps, because we're not very tall. And my 2 younger brothers are identical, are very cute. They've always been very cute. We call them the Pretty Boys. Okay. Bill is a scratch golfer. Bruce is not. And they dated the same girl for 3 months, and that young woman did not know she was dating 2 guys. They are cruel. My sister calls them the evil twins. I call them the conjugates. Bill, Bruce. Now, what's so special about the conjugates? Well, when I go through and FOIL,
A squared plus B squared.
bam! That happens every time. And you're left with a difference between squares. You have no middle term. Well, why is that so handy dandy? Well, if you have square roots, you know there's not going to be any middle term, correct? Because they will be opposites. They'll be 5 times the square root of A minus 5 times the square root of A. Why multiply them out? It's just going to be this squared minus this squared, the difference between squares. So I get A minus 25, correct?
Mm-hmm.
So when we have rational expressions like this, when you see that, what I want you to do is identify the conjugate you're going to multiply. The conjugate must have the square root in it. So the conjugate that I'm going to multiply here is the square root of x plus 25 plus 5
All over 2x.
over, remember, top and bottom have to be multiplied by the same.
But, well now, that changes stuff in my mind.
Okay, everybody see that? Now, what I'm going to get is I'm going to get x plus 25, the square root is gone, minus, because they got the difference between squares, well, 5 times 5, 25. Down here, I'll have 2x, parentheses, the square root of x plus 25 plus 5. Now, oh, I forgot this. Sorry, Austin. I knew you were looking for that, those 3 dots. Bam! Right? Another bam, right? Now notice, Audrey, I go vertically here. You know why? Because I'm not going to have a 0 on top because I've got x over x, don't I? So I'll have 1 on top. And that kind of reminds me that I have a 1. So my answer here is going to be 1 over 2 parentheses the square root of x plus 25, extend that a little bit, plus 5. And you can distribute if you want the 2. I don't go through the effort. And again, if you're one of those people that need to do that because you were told to do that 50 million times and that is ingrained into you, go ahead. I'm just not going to do it.
What you mean putting the
Right hand, the
square root
2
out
in front of the
bottom?
radical and having a 10 here. If you do that, it won't be wrong. I just don't do it.
Yeah, if it means less work, I won't do it.
Yep. All right. So here, Austin, what do you think my conjugate is?
Would it be x squared minus 8 minus 1?
X, square root of x squared minus 8, right? Square root
Yep.
minus 1, top and bottom, right?
Yep.
Okay, so down here, I have x minus 3. I always do the bottom first because it's the most complicated. Parentheses, and put parentheses around here. If I didn't have parentheses, it looks like x minus 3 times, right? Does everybody understand that? That's a different thing. X squared minus 8 minus 1. Okay, Callan, what do I get up here? Tell me what to write. Do I write the square roots? Are these conjugates? Well, I got this, and I got this, they're identical. I got plus here, I got minus here,
Oh, yeah.
I got 1 here, and I got 1 here. They look like Bill and Bruce to me. So what do you get when you multiply these two? What happens to the radicals?
They go away.
Yeah, and I'm left with what?
X squared minus 64.
No, because
X squared.
I'm doing this, aren't I?
Yeah, just x squared minus 8.
Right? And the square root's gonna be gone, so it's just minus 8, okay? Then minus, and 1 times 1 is 1, correct? Okay?
And
Now,
so
Maria, this is gonna be a little bit more work. Now, do you see why I see pleasure in this problem?
a second conjugate.
Okay, let her tell me what I'm going to get.
Yeah, because you can like factor the numerator.
Red pen, bam! Right? And that's my answer. Ariana, I'm going to write this over here, so I didn't give myself enough room. Ariana, I have issues with spacing. You'll see that. It's terrible. It's like I don't know how to work a page. I never start far enough to the left. All of a sudden, everything's over here to the right. All right, what's my conjugate, Ariana? That is perfectly correct. Ariana, do you like power? Or isn't it a big deal? You like being in charge? Sure. Pick somebody. You can't pick me. And you can't pick Teresa. Maria. I picked that, you know what? I'm kind of on Maria's side right here. Because I just picked on her, okay? Pick on somebody else. Audrey, good choice. Okay, Audrey on top, I'll do that. 3x times the square root of x plus 4 minus 2. And down here, what do I get?
X plus 4 minus 4.
X plus 4 minus 4. Am I pleased with that? Well, 4 minus 4, bam, that's gone, right? Dot, dot, dot. Then I have x plus 0, correct? X plus 0 is x. This is 3 times x times that quantity. Since I have multiplication, I can go boom! Like that. Karsha's getting really nervous right now. And so what do I have left here? I simply have an answer of 3 parentheses square root of x plus 4 minus 2 parentheses. And the denominator is gone, correct? Grace. What's my conjugate?
4 plus the square root of x.
Who are you picking? You know, I once did this, and somebody thought I was being mean. He says, I am not picking anybody because I think that's just me. just enjoy this. That has nothing to do with me, this is about enjoyment. Who you picking? Ella! Down here I have x minus 16, Ella, times the quantity 4 plus the square root of x. What do we have on top?
16 minus x.
Perfect. Do they simplify? I see people saying no.
You can.
And they be wrong.
Don't you have to take out a -1?
Right, these are opposites, aren't they,
Yeah.
right? If I put a 1 in here and put a 1 in here, I'd get 15 over a negative 15, correct? If I put 0 here and 0 here, I'd have 16 over a negative 16. And yeah, if I factor out -1, it would reverse this, so I can do this, dot, 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 and put a -1 there, okay? So my answer here is a -1 over 4 plus the square root of x. Okay? Alright. So,
That was
how are we
fun.
doing here? Doing good. We're doing okay?
Yep.
Okay. Had you ever seen any of that stuff before? Okay, so it was okay to review? Okay.
Mhm.
All right. So these notes are really short. I gotta figure out where I put them. And then I'll give you the assignment. We have a work day Friday.
Which we can use to work on the green sheet as well.
The green sheet is,
Oh,
I
never
think is
mind.
due tomorrow.
Oh yeah,
Okay.
my bad.
And, we will have a quiz Monday.
Ooh, that sounds fun.
What is for me?
So more notes.
So if you look at this side, it's blank. At least you believe it, blank. It's really a polar bear in the Arctic during a snowstorm.
I can see it.
You know, that joke went off a lot better than I think it's for
Which is Jake.
I hate that joke. Anybody know who Chloe Rogers is? You do. She went with that and would draw a picture of different animals during the snowstorm. So I have 4 problems here. In Owen, all 4 of them are limits. And this is where we're gonna take what we just learned, our algebra, and put it into practice, okay? Now, first thing I always try to do is substitution, because it's easy. In the first place I look, realize, oh, it looks like a fraction, rational expression. Let me plug it in to the denominator. I'm dividing by 0, can't be done, okay? There's no factoring here, because there's nothing squared. I see a radical, so I'm thinking conjugate. Everybody understand my thinking here? So this is what we just learned, and this is the conjugate one. Owen, would you agree with that?
Yes,
Okay, you know why I chose the plus?
because it's the opposite of negative.
Yes! It's as complicated as it gets, right? Everybody okay with that? Okay. Owen, I'm gonna write this down here. I'm gonna write this. I always start with the bottom one. I probably said that before. Okay, now Owen, I'm gonna ask you a question, and you're gonna tell me it. Not verbally, telepathically, okay? Okay, I will. Right. Come. Multiply those two for me.
You get x plus 4 plus 9.
Well, it's gonna be minus. Okay, because it's a difference between squares, right? Difference is minus, correct? Subtraction. Minus how much? You said what? 9. So I got the limit. Now notice how I write the limit every single time. Seriously, I got notes from the AP calculus gods, whoever they may be, that said you gotta make sure your students are writing the limits, otherwise we're gonna be taking off points. So that's why I'm doing this here. And you can't just write the limit as x approaches with nothing in there. That doesn't make any sense. So I'm gonna have x minus what up here? X minus? 5. Ooh, I like that because that was the problem child, right? That's the kid that's not going to the birthday party. The x minus 5. 5's not there. I get x minus 5, square root of x plus 4 plus 3, parentheses. Bam! What's left here? A 1, correct? Now, can I put, this x minus 5 is gone. I am now doing this. I now take the limit as x approaches 5, 1 over the square root of x plus 4 plus 3. Correct? The whole purpose was to get rid of that x minus 5. Can I put 5 into here? Ben, I can, right? What will I get when I put 5 into there?
9 and 3.
9 and the 3. What is the square root of 9?
3.
I know you know that. Do you have to show me you know that? No. Do you know what 3 plus 3 is?
6.
Again, something you don't have to show me. So what's my answer here?
1/6.
1/6. Do you have to show me the limit process? Yes. Do you have to show me that you're multiplying by the conjugate? Yes. What I showed you here is what you have to show me.
Seems pretty doable.
Okay? See this one, Matthew? It's number 2. Okay? What's the conjugate?
3.
Oh, first of all, I tried to substitute 10 in here.
Oh yeah, good idea.
Okay, I'm going to put 10 in here. 10 minus 1 is?
No.
Square root of 9 is?
3.
And 3 minus 3 is 0. Problem child. Correct?
Yep.
Okay. So what are we going to, what's the conjugate?
3 plus the root of x minus 1.
And up here, I'm going to write 3 plus the square root of x minus 1. And I'm going to write the limit as x approaches 10. Okay, up here, I'm going to do the top because it's more work. Parentheses. What do I get here, Matthew, on the bottom?
You get 9 minus the square root of x minus 1.
But I'm going to multiply these.
Yes, 9 minus x minus 1.
So I need this, right?
Yep.
Okay, you gotta be careful on this, because you gotta, you see what I'm saying? A lot of people just write minus x plus, minus x minus 1. And that's wrong, isn't it? Right? This is what you get, and so you're gonna have to distribute this one more time. Nine minus x plus 1. Does that look right, Matthew?
Yep.
Okay, Matthew, this is 10 minus x, correct? It's kind of like what,
Pull out a negative 1.
right, it's just like the one that Ella had, right? So I can go bam, and I have this. And you said negative 1, right? Matthew, you said negative 1?
Yep.
So I can write a -1 like this. If you want, you could write it like that. So I can put 10 into here, and I get 10 minus 1, which is 9. Ben said the square root of 9 is 3. Ben told me that 3 plus 3 was 6. So does everybody see where I get -6 is my answer?
Yep.
All right, 2 left.
What do you mean 4?
All right. Tyler, what am I going to use conjugates here? Huh? Do I have square roots?
No.
No. I have fractions, right? In a fraction? So I gotta get something called, I gotta simplify the fraction, correct? Right? So, well, maybe I could put 0 into here. If I put 0 into here, what do I get for this fraction, Tyler? Oh, -1/4 plus 1/4 is 0, so I can't do that, can I? I gotta copy it. So I got limit as x approaches 0, here I have x, here I have 4 plus x minus 4 over 4 times x minus 4. So I multiplied this fraction top and bottom by 4. I multiplied this fraction top and bottom by x minus 4. Okay, Austin?
Yep.
So Austin, now I got the limit as x approaches 0. This is going to be x over 1 times, this is going to be 4 times x minus 4. And down the bottom is going to be 4 plus x minus 4. What happens to this 4 minus 4?
X.
They cancel out.
Boom, boom, oops, I hit the x, I shouldn't have done that. But that x is left, correct?
Yes.
And then I get to do this again. Correct? The x's will be eliminated,
Yep.
okay?
Yep.
Okay. I have a tendency to go too fast, that's why. Because you're trying to write answer and all that type of stuff, so sorry about that. X goes to 0, I get excited. Sometimes I like doing these problems so much, I forget I have students in front of me, and all of a sudden people, you'll do this someday. Holy buckets, Kruger, slow down. Oh yeah, that's right, I'm teaching. I'm not just doing math for fun anymore. So I have 4 times x minus 4 equals what? Can I put 0 into here?
Yes.
Yes.
And what will I get as a number?
-16.
Negative 16 is my number. Last one. Hey, Jonah. I can't put 0 in there, it's pretty obvious, right?
Yeah.
I mean, we got death, like we've got destruction. Star Trek crashes, right? Jupiter hits Mars. The sun implodes. It's just one bad thing after another, okay? So I'm gonna leave x here. The common denominator is the product of these two. That happens every single time, okay? So up here I'm gonna get a 9 minus parentheses x plus 3, that quantity squared, over 9 times x plus 3 squared. Would you agree?
Yep.
So now, I have the limit, and this is x over 1, right?
Yeah.
Okay, x is x over 1. And so I'm going to have this on the bottom. And over here, I haven't done the top yet, I will. This is gonna be, I'm multiplying by that reciprocal, correct? So this, how do you wanna do this? Okay, so should we do this? Now, I'm gonna do it down here, minus parentheses, would you say x squared plus 6x plus 9?
Yeah.
And then distribute? Did you do that?
Yep.
And then would you do this?
Yep.
And so now I have this. Would you agree?
Yeah.
Alright, so now I got the limit, luckily I got this room down here.
We can't see the bottom.
Yep, I'll bring it right up. Is that better? X, down here I have 9, x plus 3 squared. And I wanna get rid of this x, right? X was the problem child up here. So can I factor out an x here?
Yeah.
Okay, what do I get when I factor out an x? What's left in there?
Negative x minus 6.
Negative x minus 6. Bam-bity, bam, 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 right? Okay, now I get a whole new expression in which I can put 0 into here. Would you agree with that?
Yep.
So if I put 0 into here, I get what on top?
Negative 6.
And if I put 0 on the bottom here, I'll have 0 plus 3, which is 3. 3 squared is,
9.
and this means 9 times that, right? And it gives me what?
81.
81. Now, let's say you wrote this and you went to the next problem. It would not be wrong,
But simplification.
because if they don't take points off because you didn't know how to simplify. Okay, because you just proved them. Hey, I know how to take a limit. But this is just me. Okay, I would accept either one of those. If it was a calculator problem, you gave it to me correctly in 3 decimal points, it would be correct. I would grumble
Because you didn't put in a fraction.
because that means I'd have to bring out my calc